All right, so number one, I'm going to graph this function, which is a transformation of this parent function. So you should know your shift rules, and our shift rules in this case, we've got a -1 on the outside, so that shifts this parent function down 1. The +2 on the inside of the exponent is going to shift us left 2. And finally, this 2 out front stretches the graph by a factor of 2. So you need to know the shift rules because this is helpful when it comes to determining the domain range and asymptotes. But you can also use the calculator to help us graph this function. So go to y equals, type it in. I'm even going to graph the parent function so we can see this transformation. So there is the transformed function that you'll notice has been shifted down 1 and left 2 from the original function. So I have both functions in there, but the only one we want is this transformed function right here. All right, I'm going to go to y equals and clear that one out, and then go to the table, and I'm going to graph as many small number points as I can fit on this graph. So I've got -4 and about -3/4, -3 and -1/3, -2, 1, -1, 5. And you'll notice that graph gets really close to y equals -1, but never actually reaches it. I'm going to also sketch my asymptote. And this can be tricky on a touch screen, but the barrier line is at y equals -1. And basically, this vertical shift will always tell you where your asymptote is going to be. So if we shifted up 1, your asymptote would be at y equals +1. And I think that's what this next question asks. It asks for you to determine the domain, range, and the asymptote. The domain is all real numbers. Because the graph is going left and right infinitely. You may also write it as -infinity to +infinity. Both those ways are correct. The range, it does not go up and down forever. The asymptote stops it. So it's greater than -1. You notice I didn't put or equal to because it never actually equals or it never actually touches the asymptote at -1. So the range is from -1, and it goes up infinitely to infinity. The asymptote we've already talked about. The asymptote is at y equals -1. And finally, end behavior. So our end behavior for this graph, as x approaches infinity, that's the right side of the graph. Y is also approaching infinity. So the right side of the graph is going up infinitely. I always like to put an R to remind myself that that end behavior represents the right end of the graph, which means the left end of the graph is represented as x approaches -infinity, and the left side of the graph is approaching -1, the asymptote. All right, skipping ahead to number 9, essentially it is the same thing. The parent function is y equals 1/4 raised to the x power. So this problem is just a shift of that parent function. The plus 3 is shifting the parent function up 3. The plus 2 on the inside of the exponent is shifting us left 2. There's no stretch in this problem, so I can go straight to graphing this in the calculator. So there's the parent function, and you can see the graph. We're kind of decreasing. There's a decay problem. And then when we transform it, this should take the original graph to the left 2 and up 3. And there it is. And you can kind of see again the asymptote is happening at that number from the vertical stretch. So I'm going to clear out the parent and then just look at the table of the actual problem and graph as many points as I can. So I'm going to start at -3, 7. -2, 4. -1, 3 1/4. 0, and just a little bit above 3. And you can see again the y values are getting really, really close to 3, but they're never actually touching that because that is where the asymptote lies. So I'm going to be really careful to graph this where it never actually touches. It should be getting closer and closer to y equals 3. We'll do our best to show that on the graph. Do your best to show. It's a little tricky. There's my asymptote. So the asymptote is at y equals 3. The domain, just like all of these, is all real numbers. The range, so this graph goes up infinitely, but it does not go down infinitely. So the range is everything greater than 3, or you can say from 3 to infinity. And then finally, in behavior, the right side of the graph, a little R there, the right side of the graph is the side of the graph that is approaching the asymptote. I said -3, I meant +3 right there. The left side of the graph, as x is getting smaller, y is getting bigger.